All right, let's take a look at solving proportions. A proportion is an equation stating that two ratios are equivalent. So when I solve a proportion, I'm trying to find the value for the variable that makes these two ratios proportional, okay, or makes this a true statement. The way we solve proportions is we're going to cross multiply, which means you're going to multiply the bottom of one ratio times the top of the opposite ratio. So for example, here I'm going to say, all right, 7 times x, that's 7x. And on the other side, 63 times 4, that is 252. We bring down the equal sign, and now this is a basic multiplication equation. To solve this, all I have to do is divide both sides by 7. And I get my answer, x equals 36. That's how you solve a proportion. Let's take a look at this next example here. 7 over n equals negative 6 over 3. Again, we're going to cross multiply, so n times negative 6 is negative 6n, and 3 times 7 is 21. So I have this basic multiplication equation. I have to divide both sides by negative 6. And I get the answer, n equals negative 3.5. And that's perfectly fine when you're solving proportions if your answer is a decimal or a fraction. Let's take a look at some more complex proportions. So here you see there's a lot more going on, and here you have to think distributive property. Let's take a look at this first one here. We have x minus 8 over x minus 1 equals negative 2 over 5. And we're going to do the same thing. We're going to cross multiply. So if I look here, I have x minus 1 times negative 2. That looks like this. If I write it out as distributive property, it looks like this. Negative 2 times x minus 1. And on the other side, I'm going to have 5 times x minus 8. Now, hopefully, after looking at it like this, you already know what to do. So here I have negative 2 times x. That's negative 2x. Negative 2 times negative 1. That's positive 2. 5 times x is 5x. And 5 times negative 8 is negative 40. So what do we have now? We have an equation with variables on both sides. I am going to get rid of this negative 2x. I'm going to add 2x to both sides. This leaves me with 2 equals 7x minus 40. So now I need to get rid of this negative 40. I'm going to add 40 to both sides. And I get 42 equals 7x. 7x equals 42. And finally, divide both sides by 7. And I get x equals 6. All right, next example. All right, here we have, it looks a little different, but it's the same process. On one side, I'm going to have 3 times x minus 11 equals, and on the other side, 7 times x minus 3. So let's distribute. 3 times x is 3x, and 3 times negative 11 is negative 33. On this side, 7 times x is 7x, and 7 times negative 3 is negative 21. Again, I have variables on both sides, so I need to eliminate one of these. 3x, 7x, I'm going to subtract 3x from both sides. I end up with negative 33 equals 4x minus 21. Now I need to get rid of this negative 21, so I'm going to add 21 to both sides. I get on the right, I get 4x, and on the left, I get negative 12. And all I got to do now is divide both sides by 4. and I get x equals negative 3. All right, one more example. I have here 7k minus 1 over 8 equals k minus 12 over 4. Again, cross multiply. By now, you should be getting the hang of this. So here I have 4 times 7k minus 1. So 4 times 7k minus 1 equals 8 times k minus 12. So I'm going to distribute here. 4 times 7k is 28k, and 4 times negative 1 is negative 4. 8 times k is ak, and 8 times negative 12 is negative 96. Again, we have variables on both sides, so I'm going to eliminate 8k. I'm going to subtract 8k from both sides, and I get 20k minus 4 equals negative 96. Next, I have to eliminate this negative 4, so I'm going to add 4 to both sides. And I get 20k equals negative 92. And finally, divide both sides by 20. And I get k equals negative, so 20 goes into 92 4 times, that's 80, with a remainder of 12. If I simplify the fraction 12 over 20, I can divide by 4, and I get 3/5. So negative 4 3/5, or negative 4.6.